Hello, it is a real pleasure to present my research on the BME forum. I am studying cardiac phase effects on auditory evoked potentials, which is actually pretty straightforward. We are interested in how heart is affecting our brain. To be more specific, how auditory perception is influenced by cardiac activity. Our brain is continuously stimulated by both external signals from the environment and internal signals from the body. Though we are not always aware of, inner stimuli from organs such as the heart actually play an active role in modulating the brain's perception of external stimuli. Previous work shows that cardiac function-related events have an impact on both perception and neural responses to visual and somatosensory stimuli. Both cognitive task performance as well as evoked potentials are altered when external stimuli onset at different times along the cardiac cycle. As shown in the upper right figure from L et al.'s 2020 paper, Heart-brain interactions shape somatosensory perception and evoked potentials, they found that somatosensory evoked potential, or SEP amplitudes, differ when somatosensory stimuli are given at the diastolic phase or systolic phase within a cardiac cycle. The lower right figure shows their experimental paradigm, in which subjects intermittently received weak electrical pulses to their left index or middle finger. Yet I asked whether and how cardiac activity modulates auditory signal perception in real time. So herein, our goal is to explore if the timing of auditory stimuli across the cardiac cycle affects the neural response to the stimuli. We designed an auditory tone discrimination task as shown in the descriptive figure below. Participants listened to a sequence of tones presented at a comfortable listening level. Each tone frequency was equally likely to be 500 Hz or slightly higher than 500 Hz. The frequency difference between the two tones was set for each individual subject to be near their perceptual threshold. After each tone, participants classify it as either lower or higher in pitch. We simultaneously recorded ECG and EEG to measure both cardiac activity and cortical neural responses. From the EEG, we found event-related potential, or ERP, differences in response to sound at different cardiac phases, systole and diastole. Ultimately, cluster-based permutation t-test corrected for multiple comparisons showed that tone-evoked ERP amplitude was greater for the systolic phase than the diastolic phase. We suspect that this cardiac modulation effect on the ERPs could be caused by the barrel reflex. Arterial baroreceptors are maximally activated during the earlier or systolic phase of cardiac cycle. Previous studies suggest that increased barrel afferent feedback enhances later stages of stimulus processing through a dedicated neural network, which could then direct attention to focus on external stimuli and produce higher ERP amplitudes for stimuli presented during the systolic portions of the cardiac cycle. Lots of questions remain to be answered regarding the real mechanisms behind this finding. We are now collecting more data to elucidate more thoroughly on how cardiac activity influences neural responses to auditory stimuli.